Hey guys, I'm going to run through the review for the upcoming 3B test. So starting with chapter 1, we're just simply asked to solve this equation right here. So let's get into it. I see on the left hand side of this equation that I have a quadratic. On the right hand side I also have a quadratic. So how I'm going to approach this one is starting on the right side, I'm going to expand this u minus 5 squared. So u minus 5 squared is equivalent to u minus 5 times by u minus 5, which would be equal to u squared. So I'm multiplying these together. So u times u is u squared. I'll do u times negative 5, and that's negative 5u. Then I'll do negative 5 times u, which is another negative 5u. And then negative 5 times negative 5 is positive 25. These terms in the middle can combine, so that's u squared minus 10u plus 25. So that's what this side will expand to be. So this I have on the left hand side 2u squared minus 15u and then plus 19. Plus 19. And now what I'm going to do, now that I have this right side expanded, I can combine terms by moving terms over here. And it's better to move these terms over here because while the leading term over here, so the leading coefficient is 2, for the leading term on the right side, the leading coefficient is 1. So it would be better to subtract 1 from 2 than to subtract 2 from 1, because then I'll get a negative leading coefficient, which is okay, but a little tricky with the negatives. So I'm going to subtract u squared here. I'm going to add 10u and add 10u over here, and subtract 25 and subtract 25 there. So I should be left with u squared minus 5u, and then oh my gosh, 25, 19, that's going to be minus 6. Okay, I'm going to get me back some space up here. I'll just move it up. So now this is equal to 0 because we moved everything over here. We subtracted all terms over here and subtract them over here, so over here is 0, and now I have just one quadratic on the left side, which means I can factor it if possible, and it will be factorable. It should be factorable. The one that you have and the one that I have should be factorable. So quadratics, trinomial quadratics will factor into two binomials, and so the first term is going to be u and u, since I want u times u to be u squared, and I want these terms right here to multiply to be negative 6 while also adding to be negative 5. And so numbers that multiply to be negative 6 and add to be negative 5 would be negative 6 and positive 1. Okay, now we can use the zero product property because factors multiply, and because these two factors multiply and their product is 0, that means one of them has to be 0. So I can use u minus 6, set it equal to 0, and then I can add 6 to both sides, and I get u is equal to 6. And then I have u plus 1 equal to 0. I can subtract 1 from both sides, and I'd end up with u is equal to negative 1. So my solutions are 6 and negative 1. Okay, so hopefully that was it. That can get you through yours as well. All right, moving on to 2. So use the quadratic formula to solve for x. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now we have to identify what a, b, and c are. So here is a, the leading coefficient is a, the term with x is b, and then the constant term is c. So for me, I'll write out my quadratic formula with these values. So x will be equal to negative b, so that will turn that to be positive 6. So 6 plus or minus the square root of b squared. So b squared, so if I take negative 6 and I square it, so remember that if you're plugging this into your calculator, you should plug it in with parentheses. So negative 6 squared, not like negative 6 squared. If you type this into your calculator, you're going to get negative 36, which if you plug that into your quadratic formula, you're going to get it wrong. So parentheses are important because then this will equal positive 36. So 6 squared minus 4 times by a times by c, all divided by 2 times by a. Okay, now what I like to do, so 6 plus or minus, I like to just do this part right here in a calculator. So I'll do 36 minus 4, parentheses 3, another set of parentheses with 2, and I get the square root of, so square root of 12 over 6. Okay, and then I need to simplify the square root of 12. So hopefully you guys have a calculator that will do that for you. If not, there's going to be one in class while you take the test that can simplify the square root of 12 if you just type it in. If you don't want to do that and you want to do it old-fashioned way, so do it by hand, you can take the square root of 12, and I know that the square root of 12 is equal to the square root of 4 times 3, since 4 times 3 is 12. And I know that 4 is a perfect square, so I can call that 2, and then since 3 is not a perfect square, I can just leave that underneath the radical, so square root of 3. So again, the square root of 4 is 2, and then I can't take the square root of 3, and there's no factors of 3 that you can take the square root of, so that would be fully simplified. So then I get 6 plus or minus 2 square root of 3 all over 6. And last but not least, what you're going to have to do is simplify this even further. So not quite done yet. To simplify this part right here, what we're going to do is we're going to take the 6 on the numerator, divide it by the 6 on the denominator, plus or minus 2 root 3 on the numerator, and divide it by 6 on the denominator. So we're taking both of these and dividing it by what's in the denominator. And then what we can simplify further, because I can say that 6 divided by 6 is 1. And sometimes you might have, like, I don't know, 2 divided by 6, which would then you would have to simplify to be 1/3. All right. Oh, so just like here. So we have 2 divided by 6. So plus or minus. Now here, if you can simplify the number outside, so not the number here. So this square root of 3 is done simplifying. I can't touch this anymore. I can't simplify it anymore. But perhaps I can simplify the fraction out here. Sometimes you can, sometimes you can't. In my case, I can. It's 2 over 6, which will simplify to be 1/3. So I'm just going to call this root 3 over 3. So this is 1/3. I don't care to write the 1 because I don't need to. And that would be my answer. My answer is going to be yeah, I think I can leave it like that. I think that will be okay. All right, so that's question 2. So for question 3, you're going to do the same exact thing. But you have a quadratic, it's going to have complex solutions, so it's going to have solutions with I. And so I'll show you how you can do that. We're still using the quadratic formula. So in this case, A is going to be 3, B is going to be equal to 1, and then C is going to be equal to 4. So using quadratic formula, so x is equal to -1 plus or minus the square root of 1 squared, which is just going to be 1, minus 4 times by A times by C. And then all divided by 2 times by A. Okay, so this is going to be equal to -1 plus or minus the square root of, now here we have 4, 3, 4, so I'm just going to type all of this in my calculator. So 1 minus 4 times by 3 times by 4. So -47. Okay, and then this is all divided by 6. Okay, now before you proceed any further right here, you can't do anything else. So if you are trying to put this into your calculator, just all of this right here, and pressing enter, you're likely getting a domain error. The reason why you're getting a domain error is because of this negative 47. Your calculator or calculators, whatever one you have, likely is unable to solve the square root of negative 47 because your calculator is not programmed to generate complex numbers. It can only generate rational and irrational numbers, not complex numbers. And so what we need to do here is get rid of this negative that's inside of the square root. And if you remember that the square root of negative 1 is equal to I. So the fact that I can treat this as negative 1 times by 47 means I can rewrite this as negative 1 plus or minus I square root of positive 47 over 6. So make sure that you get this I first, and then you can make it positive, and then you can plug this in. But for me, the square root of 47 doesn't simplify any further. Also, for me, I can't do 1 divided by 6, and there's no number here to simplify the 6 right here. So like up here, I was able to simplify 6 and 6 and 2 and 6. But I don't have to, but that doesn't simplify here, and so I'm actually done with this right here. But if it does simplify, Alex will probably want you to simplify, okay? But that's my answer. That's what I can type into Alex, okay? For 4, write the quadratic equation whose roots are 1 and negative 3. So write the quadratic equation whose roots are 1 and negative 3 and whose leading coefficient is 3. Okay, so let's see. Write the quadratic equation whose roots are 1 and negative 3. Okay, so if I have a quadratic equation and its roots or solutions or zeros or x-intercepts, they're all the same, they're all synonymous, are 1 and negative 3, so x equals 1 and x equals negative 3, then my factors are x minus 1 and x plus 3, just like that right there. So I can multiply these together and get a quadratic equation. So I can multiply x times x, and I'm going to get x squared. I can multiply x and 3, that's going to give me positive 3x. Multiply negative 1 and x, that's negative x. And then negative 1 and 3, that's going to be negative 3. These combine, so then I get x squared plus 2x minus 3. So I'm not finished though. I do have a quadratic with these roots right here, but I also need to make sure that my quadratic has a leading coefficient of 3. So what I can do without changing the roots, which I have already established, what I can do is I can multiply the entire thing by 3. And as long as I multiply each term by 3, that won't actually change the roots that I just have, as long as I multiply each term by 3. So I can distribute that 3, get 3x squared plus 6x minus 9, and yeah, that should be my solution right there. So this is a quadratic, leading coefficient is 3, and it has the roots of 1 and negative 3. Okay. All right, for 5. Just so you guys know, for 5, this is a pretty difficult question right here, or some of you might get a difficult one, and I would classify this as a very difficult one. I'm going to try and make sure that you guys get simple or much simpler ones, so maybe like a degree 3 or a degree 2 or something like that, but I'll try and make it so it's a lot simpler. Degree 4 can take a while to get, but I'll show you anyways. So if it's a degree 4, we need 4 factors. So degree 4, we need 4 factors. And some of these factors are complex. So we have a complex factor here. And here we have 2 factors because 1 is a factor with a multiplicity of 1. So if the root is 1, then x minus 1 is the factor. But if it's a multiplicity of 2, that means it happens twice. So x minus 1 and x minus 1. So I have 2 factors. I'm looking for 2 more. Here's another one. So for this factor, I would have to call it x minus 2 plus 3i. Okay, so here's a third factor, but where is the fourth factor? Because they only give us 3 roots, 1, 2, 3. Well, it's known that that complex numbers should always be accompanied with pairs. They should always come in pairs, and we call them conjugate pairs. And so technically there is another 0 that they're not giving us, but what we know is true is that the conjugate of 2 minus 3i. Conjugate means that its conjugate is just going to be 2 plus 3i. Conjugate means that you have the same number here, but the sign in between them is going to be the opposite sign given. So remember, these numbers are going to be the same, but the sign in between them are going to be opposite. So if that's the other 0, then the other factor is going to be x minus 2 minus 3i. So make sure whenever you're putting it in factored form that, so like if this was negative 2, this would have been positive 2. And again, if this was negative 2, this would have been positive 2. And then you always flip the sign. So basically, we're just flipping the signs as we put it with x. So like this is positive 1, so x minus 1. And then this is 2 minus 3i, so it's x minus 2 plus 3i. This is 2 plus 3i, so x minus 2 minus 3i. Okay, now another thing to note is that you need to multiply these first. We don't want any imaginary or complex values or expressions whenever we find the polynomial. So the way to make sure that happens is to multiply this first. Okay, and if you do, and you do it correctly, there should be no imaginary units. So I'll show you how you can do that. So if we take x and multiply it by x, we're going to get x squared. If I take x and I multiply it by negative 2, that's negative 2x. X multiplied by negative 3i, I'll call that negative 3ix. Okay, so now I'll move to the negative 2 and multiply by all 3. So negative 2 times by x is again negative 2x. So I'm going to write that underneath the already negative 2x. So I'll do negative 2 times negative 2. That's negative or positive 4, so I'll write that over here. I'll do negative 2 times by 3i. That's negative 3i. That's going to be positive 6i. Okay, now last I'll use the 3i and multiply by x. But when I multiply those together, I'm going to get a positive 3ix. So I'm just going to stack that underneath this one. I'll do 3i times negative 2. That's going to be equal to negative 6i. And then I'll do 3i times by negative 3i. That's going to be negative 9i squared. Okay, now let's see what we can combine. So we have x squared. This is going to be negative 4x. Those will cancel and those will cancel. This is good. Look at the imaginary units, the complex units that we have. They're going away, except for this I squared. But I squared is equal to negative 1. That follows from the square root, or that follows from I being equal to the square root of negative 1. If you square both sides, then you get I squared is equal to negative 1. So if I squared is equal to negative 1, then this turns into positive 9 because it's going to be negative 9 times negative 1, which means this negative 9 and this negative 4 are going to add together. So that's going to be plus 13. And then here is the polynomial. This is the result of the product of these two factors. But I still need to multiply these together. So this becomes x squared minus 2x plus 1 if you FOIL it out and combine the middle terms. And then what I need to do last but not least is do x squared minus 2x plus 1. So these right here I need to multiply as well. So I'm going to try and make some more room for myself. So I'm multiplying these together. And this is what I'm saying, that fourth degree polynomials aren't very nice. So I'm probably going to have to input my own questions so that you don't get something this extraneous or this crazy. So x squared times x squared is x to the fourth. X squared times negative 4 is negative 4x to the third. x squared times 13 is positive 13x squared. Negative 2x times x squared is going to be negative 2x cubed. And notice how I like to stack like terms. So I go and I stack them. So negative 2x times by negative 4x is positive 8x squared. So I'm going to stack that here. Negative 2x times 13 is going to be negative 26x. Then 1 times x squared is going to be plus 1x squared. 1 times negative 4 is going to be negative 4x. And then 1 times 13 is going to be positive 13. And I just combine vertically. So x to the 4th, negative 6x cubed. 13, that's going to be 14. Is that going to be 22x squared? So plus 22x squared minus 30x plus 13. Finally, I have my polynomial. All right, for 6, so use the rational zeros theorem to list all possible rational zeros of the following. So, rational roots theorem says that if I take factors of the constant term, so you might have to look for it here. So here's the constant term. That's the constant. And then I need to look for the leading term. So here's the leading term. It's the term with the highest degree, and that makes 3 the leading coefficient. So for the rational roots theorem, we're going to generate a list of possible rational roots by taking factors of the constant term, negative 2, and dividing them by factors of the leading coefficient, which would be 3. So plus or minus, make sure you include that for each possible factor. So factors of 2 are going to be 1 and 2, and factors of 3 are going to be 1 and 3, and we're going to generate the list. So the list should be plus or minus. I like to start with the 1 on the numerator and divide it by all terms in the denominator. So 1 over 1, that's going to be 1. And then comma, plus or minus, I'm going to do 1 divided by the 3, so that's just going to be a third. And plus or minus, now since I took this one and divided it by all the things in the denominator, I'll move on to the 2 and do the same thing. So 2 divided by 1 is just going to be 2. And then 2 divided by 3 is going to be 2/3. And that should be enough for you guys to answer this question, okay? All right, for 7, the function below has at least one rational zero. So there's at least one rational solution for this 4-degree polynomial, and we're trying to find them. So now, you don't have to use the rational roots theorem, but you kind of have to help you with this one. So instead, what I like you guys to do is we'll go into Desmos, and we'll type out the function. So 7x to the 4th, and then minus 5x to the 3rd, then minus 17x squared, then minus 3x plus 2. Okay, hopefully I got this right. All right, perfect. So if I look at this right here, I see 2 and negative 1 are my rational solutions. The other ones are irrational. So let's start with 2 and negative 1. So for your solutions, you do have 2 and you have negative 1. Okay, now for the rest of it, you're going to have to use synthetic division. So let me erase this right here. So we're going to use synthetic division with these numbers and this polynomial. And you can pick which number to start with. I guess I'll start with 2. And I have 7, negative 5, negative 17, negative 3, and positive 2. So drop to 7. 7 times 2 is 14. 14 minus 5 is negative 9. Then I get, positive 9, not negative 9. That makes it positive 18, positive 1. That makes it 2. That makes it negative 1, negative 2, and 0. All right, and then I'm going to use the negative 1. Okay, drop the 7. So that's going to be negative 7. That's going to be 2. negative 2, it's going to be negative 1, 1, and 0. Now I'm going to take this right here. This polynomial will be 7x squared plus 2x minus 1. This polynomial right here is not factorable. So to find the solutions of this polynomial, also why it's x squared, why the first term is x squared is because the first term here was 4th degree and we use synthetic division twice. So we take 2 off of the degree and that's why it's 7x squared. Now we're just going to use the quadratic formula to wrap this up. So x will be equal to, so this is A, this is B, and this is C. So x will be equal to negative 2 plus or minus the square root of 4 minus 4 times by A times by C, all divided by 2 times by A. So negative 2 plus or minus the square root, let me type that into my calculator, 4 minus 4 times 7 times by negative 1. Whoops, 4 minus 4 times 7 times by negative 1, and I get 32 over 14. I'm going to make sure that I simplify the square root of 32. My calculator doesn't simplify, so I have to do it by hand. So square root of 32, that's equal to the square root of 16 times by 2, right? 32 divided by 2 is 16, yep. And the square root of 16 is 4, so this becomes 4 root 2. So negative 2 plus or minus 4 root 2 over 14. Now, I can simplify these values right here. So I'm going to write it as negative 2 over 14 plus or minus 4 root 2 over 14, and then I can simplify these fractions. So that will reduce to negative 1 over 7 plus or minus 2 over 7, and don't forget the root 2 right there. And that should be it. So that would be the remaining 2 zeros. So I have these as all my zeros. Okay. All right, for the next one, same exact process, honestly, same exact process. Might not be as nice for the zeros though, but let's try it out. So we're going to put that into the graphing calculator. So we're going to have 3 x to the 4th plus 25 x to the 3rd plus 25 x squared minus 19x, and then plus 14. Okay, oh, actually those numbers turned out very, very nice. Very cool. How did those turn out so nice? How did those turn out so nice? So, 1 second, so we do 14. Factors of 14 are 1, 2, 7, and 14 over 1 and 3. So what were the solutions? Negative 2. Oh, yeah, no, that works out pretty nicely. Okay, yeah. All right. And so let's keep track of those. I'm glad that those were very nice. So negative 2 and negative 7. So negative 2 and negative 7. All right, so we have 3, we've got 25, we've got 25, negative 19, and 14. All right, and I'm going to choose, let's go with negative 7 first. Drop the 3, so 3 times negative 7 is negative 21. I get 4, get negative 28, get negative 3, get 21. That's going to be equal to 2, negative 14, and 0. And then I'm going to get negative 2, drop the 3. So 3 times negative 2 is going to be negative 6. And then I'm going to get negative 2, or negative 6. Negative 2 times negative 2 is going to be 4. And then I'm going to get negative, or positive 1. And then I'm going to get negative 2 and 0. So this is my polynomial, 3x squared minus 2x plus 1. And then we're going to use the quadratic formula. So we got a, b, and c. So x is going to be equal to 2 plus or minus the square root of 4 minus 4 times by a times by c, all over 2 times by a. So this is 2 plus or minus the square root of 4 minus 4 times by 3 times by 1. And I get negative 8. So I have negative root. So keep that in mind. The reason why there's only 2 intercepts here is because the other 2 are complex. So that's why they're not showing up, and that's why we're going to get imaginary solutions. So this is equal to 2 plus or minus, I'm going to make it I square root of 8 over 6. And then I need to make sure that I simplify the square root of 8. So square root of 8 is 4 times by 2. Square root of 4 is 2, so that's 2 root 2. So 2 plus or minus. Now, if I'm bringing out the 2, but there's also an I right there, that's 2I square root of 2 over 6. I'm going to split that up. So 2 over 6 plus or minus 2I root 2 over 6. And simplify this and the outer numbers. So 2 over 6 is 1/3. So 1/3 plus or minus I, or 1I, square root of 2 over 3. And that should be my solution. So there you go. All right, for 9. All right, so for 9, I actually have this here. So on the test, it will look like this right here. Let me put this here. So we're going to describe the transformations from f of x to g of x. So the and then we're going to graph it. So the transformations from x to the 4th to g of x. So I have 1/2. That's a shrink by 1/2. So a shrink by 1/2. And then with a minus 4 inside, that's going to be moved to the left 4. So move to the left 4. Okay? Now for graphing it, if you think about, remember that if it's x to the 4th, then it's going to be a parabola. If it's an even degree, it's going to be a parabola, just like x squared. So it's going to look just like x squared, honestly, just more narrow. And we are moving it to the left 4, so that means my vertex will be over here, okay? And then, honestly, what you could do is, if you want to graph it in your, make a table in your calculator, you can do that. Let me just really quickly graph the parent function. That always helps me. So the parent function is gonna have a vertex at 0, and then, so here's the parent function. If I plug in 1 or -1, it's going to give an output of 1. And then if I plug in 2, 2 to the 4th is 16. So all the way up there at 16 is going to be my next point. But now for this graph right here, we are moving these points over to the left one. So you can say that I can put a point here and here. And then I am shrinking it by 1/2. So this point all the way up here, which is at 16, if I shrink it by 1/2, it's actually going to be at 8. So then I'm going to put a point right here for that, because it's a shrink by 1/2 and it's moving to the left 4. And so my graph should look just like this right here. Okay? And then, here. Okay. And then I'm going to, for 10, I have another one. So for 10, put that over here. So for 10, I have a cubic function, so an odd degree. So that one's not going to be a parabola. It's going to, so this one's not only, so it's going to be one where it looks like this right here, but then the other side's going to be flipped, because it's an odd degree. And so the two transformations here are reflection. So reflection over the x-axis, and then up 2. So reflection over the x-axis and up 2. So let me just graph the parent function really quickly. So x to the 3rd it's going to have points right here like that. And so 1, but -1, because if you plug in -1 to the third, that's going to be -1. And then if I plug in 2 to the third is 8. So point here, and then I'll also have a point here down at -8. So this is what the parent function looks like. Okay, now we're going to move everything up to, but everything's being reflected as well. So I think I'm going to do the reflection first. So if it's a reflection, then all these points right here are going to be mirrored across the axis. So for my graph right here, if I mirror it, it's going to have a point here, point at 8, and a point at -8 here. So just like that. And then it's going to be moved up 2. So all my points are going to be moved up 2. So 1, 2, 1, 2, 1, 2, 1, 2, and then that one will be up there. So my final graph should look like this right here. Okay? All right. All right, back to the assignment that's in Alex. So for 11, consider the polynomial function. So we have these right here, and we're going to choose the graph for each function from the choices below. So for f of x, it's a 4th degree polynomial, negative coefficient, so that means the n's behaviors have to both be going down. So it can't be a or b or c. So it could be one of these 3 down here. So D, E, or F. Okay. Another thing to keep a note is that for the y-intercept, so if I plug in 0 for x to find the y-intercepts, everything is 0. So I should have a y-intercept of 0. So it's not going to be f, because this one has a y-intercept above 0. So it could be D or E. So now I'm going to check the x-intercepts. So if I factor out an x to the third, actually I'm going to factor out a -4x to the third. I'm going to be left with x, positive x, minus 3. Okay, now here, if I have x by itself, that means the x-intercept has to be 0, and it's a multiplicity of 3, so keep that in mind. So multiple of 3. So that means it should cross and not touch. And then x minus 3 would mean that we should have an x-intercept at x equals positive 3. So positive 3 and 0. All right, so both of these have an x-intercept at 0 and positive 3, but the difference here is that at 0, this one crosses while this one touches. So it can't be this one right here. If this was a multiplicity of 2 or 4 or an even multiplicity, then yes, it would touch, but it doesn't. So this one has to be the graph of f of x. Okay, and then for g of x, we have x minus 4 squared, x squared minus 4. Okay, so for this one right here, the degree, so I have 2 factors here and 1 factor here. So if I have 2 factors and 1 factor, that's a degree 3 polynomial. And the leading coefficient has to be equal to a positive number. So in that case, the left end behavior has to be going down and the right end behavior has to be going up. So it can't be any of... Wait, nope, sorry, just kidding. The degree of this factor is 2. Yes, this is 1 factor, but this 1 factor is of degree 2. So this is also a degree 2. So this is still even. And both ends are going up, so it's even and positive leading coefficient. So this could be A, B, or C. So this is going to be A, B, or C. Now, let's look for x-intercepts since this is factored. So now this can factor even more. This can factor to be x plus 2 and x minus 2, if you guys remember difference of squares. Or you could just take x squared minus 4, set it equal to 0, and solve for x. take the square root, so x is going to be plus or minus 2. And then over here, we have other x-intercepts, so this is going to be at x equals 4, but it's a multiplicity of 2, so a multiple of 2, which means it's going to only touch at x equals 4. So let's see if we have anything like that. So we have these two graphs right here. All right, and then this one doesn't even have an intercept at 4, so it can't be this one. So both of these graphs, B and C, show a bounce or a touch at 4. This one has an x-intercept at 2 and -2. This one doesn't have an x-intercept at -2, but it should have one at both. And so in that case, this B has got to be g of x. Okay, for 12, the graph below is the graph of the polynomial function with real coefficients. All local extrema of the function are shown in the graph. Okay, we're looking for decreasing, intervals of decreasing. So if you're reading the graph left to right, if you take your pencil, start from the very left, and you start tracing it, if you're tracing downwards, that means the function is decreasing. So we start decreasing, but then here we switch or return directions, and then we're going to be increasing, then decreasing, then increasing. So your question might be asking for increasing or decreasing. That's how you can tell. So -infinity to -1. This is referring to the x-axis. So if I look at the x-axis from -infinity, that direction is where -infinity is, all the way up until -1. Are we decreasing? And the answer is yes. So from -infinity to -1 on the x-axis, the function is decreasing. Okay, so that's a yes. From -1 to 3. So from -1 to 3, no. You can see here that we're increasing. From 3 to 7, so from 3 to 7, yes, we are decreasing in between there. So that's a yes. From -1 to 7, so from -1 to 7, we're not always decreasing. We have this part where we're increasing. So I'm going to say no to that one. 7 to infinity is no, because we're increasing. For B, at which x values does the function have local maximum? So if I look at this graph, I can only see one maximum, and it's right here. The x value is 3. And what is the sign of this function's leading coefficient? Well, first of all, if I take a look at the degree, so since both ends are going up, so in the same direction, it's got to be an even degree. And if it's an even degree and both ends are going up, then it has to be a positive leading coefficient. So this one's positive. Just so you guys remember, so if it's positive, if it's an even degree polynomial, if it's even, they have to be going in the same direction, either both going up or both going down. If it's a positive leading coefficient, they're both going up. If it's a negative leading coefficient, they're both going down. If you have an odd degree polynomial, you can either have one side going down on the left and the other side going up on the right, or opposite. But if it's a positive leading coefficient, then it's down on the left and up on the right. And if it's a negative leading coefficient, it's up on the left and down on the right. So that's how you can tell. Which of the following is a possibility for the degree of the function? So if I'm going to count the turning points on my function. So the turning points are all the minimums and maximums. So here, right here is a turning point because it changes from decreasing to increasing. So there is one turning point, here's a second turning point, and here is a third turning point. So I have 3 turning points, which means the least degree has to be one more than the number of turning points. So in that case, 4 is my least degree. So it could be 4. It can't be 5 because I know that I have to have an even function. So it can't be 5. That's not a possibility. It can be 6 because that is even and it's greater than 3. greater than 4. And it can't be 7, and it can be 8, it can't be 9, okay? All right, and for the last question, even or odd functions. So even functions are symmetrical about the y-axis. So symmetrical about y-axis. And to prove it, you can show that f of x is equal to f of negative x if it's an odd function. So I'm not referring to the degree either. So this one would have an even degree, but that's not what I'm talking about. We're just talking about if it's even or odd, which is, I know, confusing, but we're not talking about the degree. If it's an odd function, then it's rotational about, it's hard to, it's not necessarily a reflection across the line y equals x, it's a reflection across the y and the x-axis, I guess you can say. So reflection across y and x-axis. So meaning it will be the same if you do that. Okay, and so for that, the proof for that would be that f of negative x, a reflection across the y-axis, is equal to negative f of x, a reflection across the x-axis. Okay, so if you take a look at these graphs right here, so this graph right here can't be even because it's not symmetrical about this line right here, and it's not odd because if you take this graph, reflect it across the y-axis, which would look like this right here, and then reflect it across the x-axis, it would look like that, so they wouldn't be the same. So this one is neither. Okay. For the other one, so it's not going to be even because you can't reflect it across this axis right here. So let's say you reflect this part across the y-axis and then reflect it across the x-axis and then reflect that part across the y-axis, you would get the same thing. So this one would have to be odd. Okay, for these next two, we're going to have to prove it with this part right here. So I always check to see if this is true right here. So let's take g of negative x. So g of negative x, if I plug in negative x here, because this term has an odd degree, it's going to flip the sign. So this will turn into positive 4x to the fifth. Same thing if I plug in the negative x here, because it's an odd degree, that's going to change this term to be negative 5x to the third. So this is not the same as this right here, so it's not even. Next thing is I'm going to see what negative g of x is. So negative g of x will flip the sign of every term. So that's going to be 5x to the fifth minus 5x to the third. And then I check to see if these are the same, which they are, so therefore it's odd. Okay, and then for this next one, I'm going to do the same thing. So I'm going to try h of negative x. So h of negative x, if I plug in negative x here, it's an even degree, so that does not change the sign here. So it's going to remain 3x squared. And because h of negative x is the same thing as h of x, it has to be even. Okay. All right, that's everything that you should need to know for the upcoming test. Let me know if you have any questions.